Trigonometric identities. This is a test problem. It says 2 secant square x minus secant to the power of 4x minus 2 cosecant square x plus cosecant to the power of 4x is equal to cot 4x minus tan 4x. We need to prove this identity. Now what we can do is that we could start from either left or right, but let's start from the right hand side. And of course in this we are going to use the Pythagorean identity. So I hope you remember the Pythagorean identity can be written as one which relates tan and secant square is 1 plus tan square x equals to secant square x. Okay, that's one Pythagorean identity. The other one is that 1 plus cot square x equals to cosecant square x, right? Now if we start from the right side, what we can do is we can write what is tan square x equals to, and since we have tan to the power of 4, or we can square both sides and figure out in terms of secant what tan could be written as, right? So what I'm trying to say is that we can write this as tan square x equals to secant square x minus 1. And now if we square it, we get tan to the power of 4x, right? So we get tan to the power of 4x is equals to square of this, which is secant square x. We'll expand later, okay? Like this, right? So we square both sides. Now it is a minus b whole square, so it could be written as secant square of square will be to the power of 4x. Let me write like this, minus 2 times ab, which is minus 2 times secant x plus 1 square, which is plus 1. So tan to the power of 4x can be written as secant to the power of 4x minus 2 secant x plus 1, correct? On the right hand side we have a very similar expression, so let's write down what is cot to the power of square x like we did here. So we can say cot square x is cosecant square x minus 1. So cot of 4x, that means we square both sides, and if we do so we get here cosecant square x minus 1 whole square, right? So this can be expanded as cosecant to the power of 4x minus 2 cosecant x plus 1, correct? Now let's start writing what our right side is equivalent to. So let's start our identity now. So we'll start from the right hand side. So we say, well, right hand side is what? So right hand side is cot to the power of 4x minus tan to the power of 4x, correct? Now from here we can call them equation 1 and equation 2. So we did this groundwork so that we can understand what is cot to the power of 4x and what is tan to the power of 4x. Now we know cot to the power of 4x is this expression, right? So I can write this for cot and this for tan. So the right side now becomes equal to cot to the power of 4x. I'm writing as cosecant to the power of 4x minus 2 cosecant x plus 1, and minus, I'll put this in bracket, tan to the power of 4x is secant to the power of 4x minus 2 secant x plus 1. So that is my cot to the power of 4x minus tan to the power of 4x. Now let's simplify this. So when I open the bracket, so what do I get? I get, let me write this again, cosecant to the power of 4x minus 2 cosecant x. Sorry, this was square, so this should have been square here, right? A square b, so there is square here, and so this square will write here, so cosecant c cosecant square x, correct? Similarly, this one is 2ab, so this should have been square here. Let me correct this, okay? Now let's go back to this again. Tan to the power of 4x is secant square x minus 1. So the expansion for this is a square minus 2ab, right? So a square is secant square square, which is 4, 2 times a, which is secant square x, right? Times b is 1. So it is secant square x plus 1 square. That's how we get. And here also 2 times ab, a is cosecant square x, so therefore this should be square, right? So that's what it is. And now let me use this pen. So cosecant square x and plus 1 minus 1 will cancel out. So when we open the bracket, we get minus of secant 4x minus minus becomes plus 2 secant square x. So we get these 4 terms. Now we can reorganize as written here. 2 secant square x, it could be written as 2 secant square x minus secant to the power of 4x, and then we write minus 2 cosecant square x plus 4 cosecant to the power of 4x, and that is the left side, correct? Now we know right side is equal to left side, and therefore this identity has been proven. Okay, thank you.